Good afternoon, everyone. In the previous class, we have started discussing, we have completed our discussion on adder experiment. Till now, we have completed 4 experiments. In the digital part, we have discussed about the adder and the subtractor. The adder, which is the circuit which is going to be present in the ALU, arithmetic logic unit, which we use for arithmetic operations. And we have discussed the advantages of the half adder and the disadvantages, the limitations of half adder, why we went for the full adder. It is just a operation of 2 bits. If there are operation of more than 2 bits are there, then you have to use the full adder. And that is what we have discussed, and we have shown the circuit also. That is the meaning of this word design. Design and implement is you have to show how did you come up with that circuit. First, you have to write the truth table. After that, you have to write the circuit. That is the minimal expression you have to write first. The minimal expression, how to minimize the expression, that is using the K map. After that, for the minimize expression, you have to draw the uh, circuit. That is what the complete procedure. Then it is implementing on the trainer kit. That is what it is, the design and implement. The same thing you have to do it on the software in the Xilinx software, but it is not a free version. It's a license version. We are trying to show you. Someday we will try to install and we will show it on the lab if possible, or from the lab itself. Maybe the instructor will show you the software how to use that. But as of now, in the online class, we'll discuss all the software part or the design part in the online lab. We'll just discuss how to design that. And if you want to implement really on the hardware, then the only option is that you have to do it in the lab itself. Even though if you use the simulation softwares and if you just place the ICs and if you see the output, it is of no use. You have to really test the hardware and feel how it is, what is the structure, how you have to connect everything on the trainer kit. If you do it, then only it will be completely understood. Today we will discuss the fifth experiment, that is, given a 4 variable logic expression, we have to simplify it using the appropriate technique and realize the simplified logic expression using 8:1 multiplexer. We'll understand the problem statement first. 4 variable logic expression. 4 variable means A, B, C, D. Given a 4 variable logic expression means in the runtime we will give any expression. Y equals A, B, C, D plus A bar, B bar, C, D plus A bar, B bar, C bar, D bar plus A, C bar, D. Any expression. It can be in the test or it can be in the exam. In the runtime, we will write one 4 variable expression. That expression you have to realize. Realize is nothing but truth table. The next to that, you will write the output. Because we'll give, given the 4 variable expression means, we'll give the min terms. We'll give the min terms like this. We'll give the question like this. Given a 4 variable expression means, we'll give the min terms and the don't care conditions. Given that, what we should do is, you have to realize the logic expression. Realize means using the IC, you are going to enter those 4 values A, B, C, D, and you have to see that output. Appropriate output you have to see, because you know A, B, C, D, and what is the output also you know. For 2, 4, 5, 7, 10, 11, 14 should be 1, and for these things don't care means it can give you 0 or 1, and this is the output you should see on the IC. It is very simple just to realize. Give the inputs for A, B, C, D, 4 zeros. From that circuit it has to give 0. For 0, 0 and D for 1, it should give the output low 0. For these terms, it should give high output. For these terms, it should give low or high. It is based on our assumption. And for all others, it should give low output. That is the meaning of the word realize. But the catch here is they are not going to give you to enter all the four variables, means they are giving you 8:1 multiplexer. In order to realize, four variable expression, 2 power 4, 16 values, 16:1 multiplexer is required. In order to realize four variable logic expression, 2 power 4 control inputs, 2 power 4 control inputs, 16 values, 16 values you have to enter inputs, then you will see one output. For that 16:1 multiplexer, it should be there. But what is the question here is, they are going to give you yes, this 8:1 multiplexer we can easily realize using 16:1, but using the four variable expression, how can you realize using the 8:1? 8:1 is nothing but 2 power 3, 3 means control inputs. 2 power 3, 3 is the control inputs, and all the 8 pins are the data inputs, and there will be one output pin. How to realize that? How to reduce this four variable logic expression to realize in using the 8:1 multiplexer? That is what this experiment. You have to use some appropriate technique. Some technique you have to use, and uh, you have to realize it. See, the technique what we are using here is EVM technique, entered variable map technique. And if you want to know about this multiplexer, see, multiplexer is many inputs, one output. The real-time example of a multiplexer is, see, all the computers, there will be a connection with the Ethernet. Ethernet cable will be there. From all the Ethernet cable, one end is connected to this system, and in the lab, the other end is connected to the switch that is there in the server room. In the server room, you can observe there is a switch. To that switch, all the computers' Ethernet cables are connected. From that switch, it is connected to the another switch with one cable. All the data which is coming from all these system, it is entering that switch and it is moving to the another switch with using only one cable. So many inputs and one output. It's a real-time example of a multiplexer. We'll now go through the experiment. Multiplexer is many to one. In the uh, lab, you will see, you will get the IC called 74251 IC. There is one more IC is there, 74151 or 74251. It's an multiplexer IC. What all the pins are there in this multiplexer IC is, in the theory part, I think you have studied this multiplexer IC. There will be a data pins. This is an 8:1 multiplexer. Data pins D0, D1, D2, D3, D4, D5, D6, D7. It's a 16 pin IC. Ground and VCC will be 8 and 16. See, this is for in the trainer kit, you have to connect to the ground pin 8 to the 16th pin to the VCC plus 5 volts. Then this D0 to D7, these pins are 4321, 15, 14, 13, 12. Two pins, there are output pins 5 and 6. One will be the complement of the other. Q and Q bar. We are interested only in Q. That is why we don't connect the Q bar. Control inputs means which pin it should be selected out of D0 to D7. Which pin should be selected for the output? Whether the data input D0 should be selected, D1 should be selected, that will be decided by these pins A, B, C. They are called as select pins. Since there are 8 pins, 3 control pins, 2 power 3, 8, that is 8 data pins. If you connect D0 to the 1, if you connect D0 to the 1 is nothing but VCC. If you connect that, if you want this output, D0 output in the 5th pin, if you want that high output in the 5th pin, this line should be selected. Inside, this line should be selected and all the others should be disabled. D1, D2, D3, D4, D5, D6, 7, all these inputs should be disconnected and only whatever is there in the D0, it should come out. If you send 1, the 1 should come out. If you send 0, the 0 should come out in the queue. If you want to do that, what should be the control input for this? 0 means binary representation, 0, 0, 0. It wants to select D1 and you have to discard all the others. Then you have to give 0, 0, 1. Then whatever you have connected the data 1 input, that will come out in the 5th pin. 1, 1, 1. If you give 1, 1, 1, MSB is A pin. 1, 1, 1 means 7. Then D7th 12th pin is selected. If the 12th pin is connected to the high input means VCC, then what will be the output Q? It will be 1. It is not going to see any other pins. Just the select pins, it is going to select the particular line. It will activate this line and it will disable all these lines. If you send 0, 0 will come. If you send 1, 1 will come. Therefore, these three are called as, these ABC are called as select lines. It will select the data inputs. I think now this is clear. There is one more special pin is there, enable pin. See this enable pin, which is called as an active low pin. Active low pin, it is like a switch, but it is a reverse switch, which follows reverse logic. If you connect it to ground, you can use this multiplexer. If you connect this to the ground, you will get a correct output. If you connect it to VCC, you will get always only high output. You will get always high output. Even if you give any values to ABC, even if you give any values to this data pins, it is not going to see all these pins. It will give only direct output 1. Input strobe pin, if it is low, it will activate this IC. However you want, you can use it. That is why this enable pin, which is also called as active low pin or input strobe pin, which is going to activate this IC. The other two pins are ground and VCC. The other two pins are ground and VCC. Now, we'll see how we are going to reduce the 16 values to 8 values. We have to reduce 16 values to 8 values. Then only you can realize using 8:1 multiplexer. If you don't reduce 16 values to 8 values, then you cannot realize, because 8:1 multiplexer you have to use. How to reduce? There is a technique called EVM. EVM technique is entered variable map technique. What is this entered variable map is, how many variables are there in that one variable will be selected as a map entered variable. If there are 10 variables, take only one variable as map entered variable. That will enter the map, because we are going to reduce that. It is that variable, it will enter the K map. Now, the 4 variable, it will become a 3 variable. 3 variable means 8 outputs. When you write a K map, it was A, B, C, D on the both the sides. When the variable, it will enter the map means in the place of 1, 0, that variable will come D, D bar. Therefore, at the outside, if you check, A, B, C will be there. That's all. That is why it is called as map entered variable. Don't worry about the real meaning of that. Just try to understand this. See, one variable out of A, B, C, D, I have taken only one variable D. That is a map entered variable. Output will be there. That is given in the min terms. You have to compare the two cases, because 16 values you have to reduce to the 8 means you have to select two values and you have to give one values. Therefore, 16 by 2, you will get 8 values. Therefore, two values I am going to take 0, 0, 1, 0. See how the output is going to vary on the input to D map entered variable. If the D is 0, output is 0. If the D is 1, output is 0. Means there is no importance of this D. D doesn't matter on the output. Therefore, the entry in the map entered variable K map will be, it is 0. MUA map is 0. For 0, the output will 1, and for 1, the output will be 0. It is exactly complement of the D. That is why it is D bar. Next, 0, 1, 1, 1 means it doesn't care for D. It will directly give always 1. Therefore, the output will be 1. The other case, 0, 0, 1, 1 means exactly same D. 0, 0, 1 don't care, because in the expression we will also give don't care. In that case, I am going to assume this don't care as 0. I can assume it as 1 or 0. I'll assume it as 0. Then it is equal to this 0, 0, 1, 0. Therefore, the output is 0. Don't care, however you want, you can assume. Usually, you have to assume the previous output. If it is 0 is there, assume this as 0. If 1 is there, you assume it as 1. That will be better option. See, 0, 1, 1 don't care, the output will be 1. Don't care 0, 0. Don't care 1, 1. If both are don't care, then directly you can write don't care. This is what mat enter variable. This logic, we have to use it in the table to reduce. We are going to use this logic in the table. Now we'll go to the problem. See, this is the 4 variable logic expression. F of ABCD summation of M 2, 4, 5, 7, 10, 11, 14. Now what we're going to write is, we'll write ABCD Q. First table we are going to, we'll write. All the 16 combinations we'll write, and we'll write Q. This is simple. Just by seeing this expression, you can write the truth table. That is not a difficult task. The next thing what you have to write is, you have to decide, in order to realize out of 16 values, you have to reduce it to 8 values. Those 8 values will be D0 to D7. D0 to D7. Why these are D0 to D7? Because they are the data inputs in the multiplexer. 8 pins, D0 to D7. What will be ABC? ABC will be the control lines. ABC will be the control lines. Now, I have written 4 columns A, B, C, D, then one Q. Everything is written. Now I have to find out what is D0. I'll separate this D from these 3 inputs, and I'll write very close to each other D and Q. Now, divide the table into two parts. Decimal values 0 and 1, one group. 2, 3, another group. 4, 5, another group. In the same way, if you divide, there will be 8 groups. Now start comparing D and Q. 0, 0, 1, 0. Don't see this expression itself. Directly you write D0 equals, if D is 0, output is 0. If D is 1, output is 0. Therefore, D0 will be 0. Here, complement version. Therefore, D1 will be D bar. Don't write this statement also. Directly you can write the expression D bar. Here, it is not going to depend on D. It is 1. That is why 1. See here 0, 0, it is same, that is why D. Here both are don't care, don't care. If both are 1, 1. Both are don't care, don't care. 1 don't care means here I will assume it as 1. That is why the output with D7 will be 1. For this expression, you have got the output like this, D0 to D7. For another expression, I will write D0 to D7, it is going to vary. It is going to change. This is what the design procedure. Truth table, map entered variable logic you have used, and you have decided D0 to D7 values. What is the meaning of that is 0, 0, 0, 0 or 0, 0, 0, 1. If you give, the output will be 0 itself. If ABCD is 0, 0, 1, 0 and 0, 0, 1, 1, the output will be the complement of D. Now you have to start the connection. Whenever you want to do the connection, you have to take the IC 8:1 multiplexer IC 74251, place it on the trainer kit, connect the ground and VCC, 8th pin and 16th pin, connect the input strobe pin, 7th pin to the ground, because in order to activate the IC. After that, connect the ABC to the inputs. Connect the ABC to the inputs. Q to the output. Q to the output. What about this D0 to D7, where you have to connect? Where we have to connect is, you have to see this. You have to see the truth table where you have to connect. D0 you have to connect it to ground. D1 you have to connect it to D bar. D bar means with the ABC inputs, you have to take another input called D. You have to take another input called D, that you have to connect it to the NOT gate first pin. From the second pin, you will get the inverse of that. So there you have to connect it, D1. What about D2? You have to connect it to VCC. D3, you have to connect it to the input D. D4, you can connect it to either 0 or 1. It is left to you. D5 to VCC, D6 to any ground or VCC, D7 to 1. This is what the connection. Everything is done now. What you have done? You have done all the connections. ABC, D, you have connected to the inputs. ABCD, you have connected to inputs. Ground and VCC, you have connected 8th and 16th pin. 6th pin, we are not going to connect. 5th pin to the output. 7th pin to the ground, because in order to activate this IC. D0 to D7, you have to see the truth table and you have to connect. Next, switch on the trainer kit and start. A, B, C, D, you have to give 0, 0, 0, 0. Whenever you give 4 zeros, in the in the 8:1 multiplexer, which line is going to selected? 0, 0, 0 means D0 will be selected. If you have connected to ground, you will get the output as low output. If you connect it to VCC, you will get the output 1. Next, 0, 0, 0, 1. In that case also, you are going to get the output from D0. Same, you have to start realizing the truth table. Realize the truth table means give the inputs A, B, C, D and see the output Q. That is the meaning of realization. Output pin is there, 5th pin. You have to see the output. And the input pins are there, 4 pins. You can see the output. That is the experiment. See, this is what the connections for that. 74251, Q bar. Q is connected to the output, D0, D3, everything connection to the VCC or to the ground. If in case if you get in the truth table, if you get D bar, then NOT gate is required, or else even NOT gate is not required. If you just want D, from the input, you can directly connect it to the pins. Data pins you can directly connect. Data pins are D0 to D7. If there is D bar, then you have to bring the 7404 NOT gate IC, and from D you have to connect it to first pin. From the second pin you will get the output that you can connect to wherever you want. That is the meaning of realization. I think it is clear, and 100% you want to be clear about this experiment means you have to see the real hardware components and you have to see the output there itself. And this is what we can do it in the online. You can show the design and you can show the ICs and what is the design procedure. If you have any doubts, you can contact me in the WhatsApp or in the next class. And you please write this experiment in the record. Thank you.